Cheese, a culinary delight enjoyed worldwide. But behind its creamy texture and sharp tang hides a little-known secret, a massive waste stream called whey. Cheese-making generates vast amounts of this watery byproduct. In fact, for every pound of cheese produced, nearly 9 pounds of whey are left behind. This is no small matter. This leftover liquid, known as second cheese whey, poses a significant environmental challenge. Rich in lactose, proteins, and salts, whey doesn't play nice with our ecosystems. Dumping it untreated into waterways wreaks havoc. It depletes oxygen, killing fish and other aquatic life. It disrupts the delicate balance of nature's water systems. Clearly, we need a better solution for dealing with this cheesy conundrum. The traditional methods of dealing with whey, such as using it as animal feed or extracting its components, are often insufficient. They can be costly, energy-intensive, and fail to fully address the sheer volume of the problem. This is where innovation comes in. What if we could harness the power of nature itself to clean up our act? What if the solution to cheese waste lies not in complex industrial processes, but in the tiniest of creatures, microorganisms? The natural world is teeming with unseen life. Microorganisms invisible to the naked eye are the planet's ultimate recyclers. They break down organic matter, transforming waste into valuable resources. This remarkable ability of microbes offers a promising avenue for tackling our cheese whey problem. Instead of viewing whey as a nuisance, we can start seeing it for what it truly is: food for microbes. By providing the right conditions, we can encourage the growth of beneficial microorganisms that can digest and break down the organic components of whey. This process, known as biodegradation, transforms a polluting waste stream into harmless byproducts. Imagine a system where nature does the heavy lifting, where instead of relying on energy-intensive processes, we enlist the help of microscopic allies. This is the promise of aerobic biological treatment using indigenous microorganisms. It's a sustainable, environmentally friendly approach that aligns with nature's own recycling system. Not all microbial processes are created equal. When it comes to breaking down waste, oxygen is key. Aerobic degradation, as the name suggests, relies on the presence of oxygen. This is in contrast to anaerobic digestion, which occurs in the absence of oxygen and can produce methane, a potent greenhouse gas. Aerobic treatment offers several advantages for whey management. Firstly, it's incredibly efficient at breaking down organic matter. The presence of oxygen allows microbes to completely oxidize the lactose, proteins, and fats in whey, converting them into carbon dioxide, water, and other harmless substances. This process significantly reduces the organic load of the whey, making it safe for disposal or further treatment. Secondly, aerobic treatment is generally faster than anaerobic digestion. This means shorter treatment times and a quicker turnaround for managing large volumes of whey. And because it doesn't produce methane, it has a lower carbon footprint, making it a more environmentally friendly option. The beauty of using microorganisms for whey treatment lies in their adaptability. Instead of relying on specialized, lab-grown cultures, we can harness the power of indigenous microbes, those already present in the local environment. These microbes are naturally acclimated to the local conditions, making them highly effective at breaking down whey. Think of it as a form of biomimicry. We're simply replicating what nature already does so well. By creating the right environment, with adequate oxygen, nutrients, and temperature, we can stimulate the growth of these indigenous microbes. They, in turn, get to work digesting the whey, converting it into harmless byproducts. This approach offers a sustainable and cost-effective alternative to using commercial microbial cultures. It taps into the natural biodiversity of the environment, promoting a resilient and self-sustaining system for whey treatment. The promise of using microbes to clean up cheese whey isn't just theoretical. Researchers around the world are putting this concept into practice, with promising results. Lab-scale experiments have demonstrated the effectiveness of aerobic treatment in significantly reducing the organic load of cheese whey. These experiments have paved the way for pilot-scale studies, taking the technology out of the lab and into real-world settings. In these pilot projects, researchers are testing different reactor designs and operating conditions to optimize the treatment process for maximum efficiency. The results are encouraging. Pilot-scale studies have shown that aerobic biological treatment can achieve high rates of organic load reduction in cheese whey. This means less pollution, cleaner water, and a more sustainable cheese-making industry. Section 6. Shrinking the environmental footprint, a win for our planet. The environmental benefits of using aerobic biotreatment for cheese whey extend far beyond just cleaning up wastewater. By reducing the organic load of whey, we're also minimizing its potential to pollute our rivers, lakes, and oceans. This, in turn, protects aquatic life, preserves biodiversity, and helps maintain the health of our planet's precious freshwater resources. But the benefits don't stop there. Aerobic treatment also helps reduce greenhouse gas emissions. Unlike anaerobic digestion, which produces methane, aerobic treatment primarily releases carbon dioxide. While carbon dioxide is also a greenhouse gas, its global warming potential is significantly lower than that of methane. By choosing aerobic treatment, we're opting for a climate-friendlier solution for managing cheese whey. Section 7. Simplicity at its finest, easy implementation for all. One of the most appealing aspects of aerobic biological treatment is its simplicity. Unlike complex industrial processes that require specialized equipment and expertise, this approach is relatively straightforward to implement. The basic requirements are simple: a reactor vessel, an aeration system to supply oxygen, and a way to monitor and control the process. The reactor itself can be as simple as an open tank or as sophisticated as a closed, automated system, depending on the scale of operation. The aeration system can be as basic as diffusers bubbling air into the whey, or as advanced as mechanical aerators that ensure optimal oxygen transfer. And because we're using indigenous microbes, there's no need for expensive, commercially produced cultures. This makes the technology accessible and affordable even for small-scale cheese producers. Section 8. A sustainable future. Way forward with biotreatment. The future of cheesemaking doesn't have to be clouded by waste. By embracing innovative solutions like aerobic biological treatment, we can transform a polluting byproduct into a valuable resource. This approach not only addresses the environmental challenges posed by cheese whey, but also opens up new possibilities for a more sustainable and circular economy. Imagine a future where cheese production goes hand in hand with environmental stewardship, where instead of being discarded, cheese whey is seen as a valuable input for other processes. The treated whey, now free from harmful pollutants, can be used for irrigation, as a nutrient source for growing algae for biofuels, or even as a feedstock for producing bioplastics. This is the promise of a circular economy, where waste is minimized, resources are used efficiently, and industries operate in harmony with the environment. And aerobic biological treatment, with its simplicity, effectiveness, and environmental benefits, can play a key role in making this vision a reality. Section 9. Joining the Wheyvolution, a call to action. The challenge of cheese whey is significant, but the solutions are within reach. By embracing innovative approaches like aerobic biological treatment, we can turn a waste problem into an opportunity for environmental stewardship and economic growth. This is not just a task for scientists and engineers. It requires a collective effort from all stakeholders, from cheese producers and policymakers to consumers and communities. We can all play a role in supporting the development and adoption of sustainable solutions for managing cheese whey. Choose cheeses from producers committed to sustainable practices. Advocate for policies that encourage waste reduction and resource recovery. Support research and development of innovative technologies like aerobic biological treatment. Together, we can ensure that our love for cheese doesn't come at the expense of our planet's health. Let's join the Wheyvolution and create a more sustainable future for this beloved food.